We'll talk about graphing transformations. And what we like to do here is utilize simple shifts and stretches that can be applied to all parent graphs that you learned in Algebra 1 and Algebra 2, parabolas, cubics, radicals, hyperbolas, and more, as well as to arbitrary graphs like the one we have here, which could be represented by a piecewise function, but in this particular case, we're going to shift this whole graph. What I would like you to remember or recall is that the a value is the vertical stretch. Anytime you have an a value greater than 1, it will be a stretch. If it's between 0 and 1, it's going to be a vertical compress. The other ones that are familiar to you should be an h value. Now, the horizontal shifts are always counterintuitive. So a plus h actually moves it left, a minus right. And then the k value, which is the vertical shifts, a plus moves up, a minus moves down. The new one here that we're not going to do today, but we will see in the future, is a b value, which is going to be a horizontal stretch or compress. And just like the horizontal shift, it's counterintuitive. So bigger than 1 actually compresses it horizontally, whereas a fractional value between 0 and 1 stretches it horizontally. But not today. We're going to start simple. So here we have h of x plus 3 minus 2. So what that is a left shift of 3 and a down shift of 2. When you're shifting any graph, whether it be a parabola or some arbitrary graph like this one, you'd like to highlight a few of the important points as the ones that you want to shift. So those are usually vertices, intercepts, any transition points, things like that. So if I take those points here that I just identified and I shift them left 3 and down 2, I'm probably going to do that all at once because it's not very difficult. Take each point, I move them left 3 and down 2, and that will be my new point. And that should give me the new graph. So I have that section, and I have this little parabola section here, and then a horizontal line. Oops. And that will be this first one. In a second color, I'll do the second one. Now we have to pay attention to order of operations. Multiplication comes before addition and subtraction. So I'm going to have to half my graph first and then move it up 1. I'm still talking about the original. So if I still reference those points, half of 0 is 0 and then up 1. Half of negative 1 is negative a half, up 1. Half of negative 2 is negative 1, up 1. Half of negative 1 again is negative a half, up 1. And half of 1 is a half, up 1. And that gives me a vertically compressed, a little bit harder to interpret, graph of what I had originally. So vertical compression would be that it's been smashed down from top and bottom. And last here I have letter C. And that negative value there is actually going to be a reflection, a vertical reflection, so over the x-axis. And up 4, again, order of operations must apply. Now, the part that some people struggle with here is they see that negative h of x, they get a little confused about what happens. Remember, h of x is a fancy way to say y, so negative y plus 4. So all you're doing is taking your y values and multiplying by negative 1. So if I take negative 2 as my y value times negative 1, I get positive 2. And then I move it up 4. If I take negative 1 times negative 1, I get positive 1, and I go up 4. And this sort of takes care of everything then without worrying about reflecting and shifting and things like that. Negative 1 times negative 1 is 1, up 4. This is positive 1 times negative 1 is negative 1, up 4. This is 0 times negative 1, which is 0, and then up 4. So you can see this linear portion here. Then I have that little parabola section here. And then I have a horizontal section. And that's transformation, graphing transformations.